Dependent sources. Independent sources do not depend on any parameter. On the other hand, dependent sources are dependent on some voltage or current somewhere else in the circuit. There are four types of sources. We have voltage controlled, voltage sources, we have current controlled, voltage sources, then we have voltage controlled current sources, and finally, current controlled current sources. So we typically use acronyms for these sources. We call this a VCVS. This is a CCVS. This is a VCCS. And finally, this is CCCS. Now, to highlight these things, I should say that you could see that there are two controlled by voltages, and there are two controlled by current. But we still have the same voltage sources as we did before, and we still have the same current sources that we had before. So that's what we mean by that. So what's a good example of this? To get a sense of what do I mean by all of this, what we're going to have here that we will use in lab quite a bit is called an operational amplifier. And typically they go by the acronym op amp. and it's the micro amplifier 741. It's definitely one of those amplifiers that's sort of like a workhorse. And this amplifier or op amp is a voltage controlled voltage source. So again, this is what controls the source, and this right here is the output. So once again, this is the controlling part, and that is going to give us the V input. This guy here is the output voltage, and this is going to give us V out. So the way it works here is where V out is going to equal to V in, and then there's a scaling factor that's constant, where A is called the gain of the amplifier. So all amplifiers should work linearly in this course. So picture-wise, what do we see here? What we have here is that we identify a dependent source with a diamond, and it has plus and minus just like anything else. So this guy is going to be our output voltage. So when I look at a circuit, what we could find here is that we could have a complicated circuit. Let's say that this is a complicated circuit, and there's many elements within this block right here. And so if I come over here, let's say that we only look at two of the branches. Somewhere in this complicated circuit, I could have an element, whatever that element is, that's connected between these two branches right here. And this element here is going to have a voltage drop, which is what we'll call Vn, the V input. So then you're seeing here is that the voltage that we're grabbing here, this is from somewhere else in the circuit. This is the controlling voltage. So we have to wire this guy somehow back into the circuit, or into the source, excuse me. And then this guy here is our dependent voltage source. So once again, I said it, but I didn't write it. So this becomes really important. This element must be wired into the dependent voltage source so that it knows it's controlling voltage. It can't just magically happen. So let's look at some of the details and then we'll label them. So here are the details. So the controlling element is independent of the source. So this is usually the voltage or current of a resistor. So if I look at the resistor, then that tells me that if I have a resistor, then that means I'm going to either be talking about the voltage being the controlling voltage, or I'll be talking about the current. That's the control. The controlled element is dependent is, I should have said it's the dependent part of the element. And what I mean by the element is that I mean the op amp. This is the source or the controlled voltage or current source. Initially, we will label them with the D as the dependent voltage source, I'll call VD initially, and the dependent current source, I'll call ID. So let's list the 4 types of dependent sources. So the first one we'll look at the voltage controlled voltage source. So I have a resistor. And somewhere in the circuit, this resistor is going to have a controlling voltage. That means we got to wire this resistor into the source. So now, somewhere in the circuit, I'm going to have my dependent voltage source. So if this guy is this guy, then I'm going to say that this is the voltage. So then I'm going to say that this guy now is going to be VD, and it's going to have some gain, which I'll call just A1. And again, here's my controlling element. So again, when I look at this, this guy is the output voltage, This guy is the input voltage, where the units of A1 will be in units of volts per volts. So again, I have to connect that resistor to that voltage source. So then I come to the next one. So the next one then is going to be our current controlled voltage source. So again, focusing on the resistor, a little bit later on, it's not going to just be about a resistor. It'll get more complicated. I'm going to focus on the current. So the current is going to control this. So now I have to connect with wires, this guy here. And then here's going to be my dependent source again. And because this is a voltage source, I'm going to do this. So now my dependent source is then going to have a different gain that operates the same way here. So if I look at the units, again, our units then tell us that the gain in this situation, this gain tells us that it must be in volts per amp. So it's a different gain. Then the third one here, we're going to have a voltage controlled current source. Again, focusing on the resistor. And you know what? We've already done this. So how about if I just copy this and just bring it down and then modify it? So if I paste this, I have this right here. So now what I got to do here is that I got to modify this here. So what I'm seeing here is that if I have a voltage controlled current source, then that means I have a different type of source, and this guy is going to now have a current that's going to be current controlled or current dependent, but controlled by the voltage. Again, if I look at the units tell us that the gain must have different units, which in this case, I should call this guy 3. So this would be A3. And this guy has units of amps per volt. And then the last one, which will be our current controlled current source. And what we'll see here is that, again, using our previous one, we can modify this a little bit. And do this. So now we don't care about the voltage, we only care about the current, which is the controlling element. So now, when I look at this, this is our current controlled guy. And so when I'm looking at this unit-wise, it has to have a different gain. Which I did not modify that. And so this gain here then has units of amps per amp. So let's look at an example. To give us a sense where we're headed on this. So what is the gain in each circuit. So let's say that I have a circuit that looks something like this. And I have a voltage source here, independent voltage source. And this is a current-controlled current source. And then over here, I have a resistor. So here's my voltage source. Here's my resistor. And I'm going to say that I'm going to look at this current of this resistor here. And we were able to measure this with an ammeter, and we know that it has 8 amps. So this guy over here is a current-controlled current source. And we're going to say that this current here is going to have a value of 32 amps. So by just looking at this, we could see here that a current-controlled current source has ID equal to AIC. So when I look at this here, I can write this. So just by inspection, we could see that the current of the dependent source is then going to be 32 amps. And this is going to be our gain A. Wow, look at that, amps and that. So how about if I label this with 1? Just to separate it from the amp. And then our current controlled, we see here that it's 8 amps somewhere else on the circuit. So then this tells us here by inspection, the gain of this amplifier, which is what we call A1, is going to be 32 over 8, which then tells us that the gain is 4 amps per amp. And that's what we define as A1. And that's how I get the gain. Now, another way that we can look at this thing here is that, let's say that we have a different circuit, and let's draw this one like this. So I'm going to have a voltage source, and this voltage source is going to have a gain right here. I mean, a dependent source right here. And then over here, this is an open circuit. Okay, this is an open circuit. So, oh, I made a mistake. I need to add something. So I'm going to have to move this stuff over here. So what ends up happening, I need to put in a resistor right here. Now I can connect my circuit. So my circuit now looks like this. So I know I have a resistor here, and we're going to say that this resistor has a voltage of V1. So when I look at this voltage source, I'm going to say that this is a voltage-controlled voltage source. So what is controlling this voltage? That voltage V1. Now, I'm still having space issues, so I'm going to bring this down even more. Now, what we're going to do here is that we're going to use 2 meters. I'm going to take a meter and I'm going to attach it, and I'm going to call this my voltmeter. I have a voltmeter here, and I have another voltmeter here. So that means I can measure elements with a voltage value. So this is my voltmeter. So then I have a red lead. And by the way, even though I said it before, this is an open circuit right here. And then I have my black lead. And then this is my black lead. So in each of these situations here, what we're going to see here is that this guy is going to measure a voltage of 2 volts. And in this situation, this guy is going to measure a voltage of 8 volts. So even though I said it, but I didn't write it, I'm going to say that these orange things are voltmeters. So, and just to be careful here, this is my red lead, and this is my black lead. And so typically when we say it's a black lead, that typically has a minus sign. And of course, this has a plus sign. So we're looking at symbols on these leads that look like that. So now, if I look at my voltage controlled current source, so my voltage controlled voltage source, then I see that what I'm seeing here is that I'm seeing this. I have my output voltage, which then reads V1 like that. Now, that 8 volt, the voltmeter on the right side measures the voltage of the output. And this guy clearly reads 8 volts. But we can see here by inspection that the voltage, the controlling voltage V1, has to be 2 volts. So in other words, this has to be A2 times 2 volts, and this equals 8 volts. So then this tells us here that the gain is then going to be 4 volts per volt, and that's our gain.